Good evening, everyone. I hope you guys are doing well. This is going to be my third attempt, I think, at trying to record this lecture. First one, my microphone wasn't working, and then the last one, my daughter came storming in here with a bruised up knee and thought she needed my attention. Okay, so what we're going to talk about today is Chapter 4, Chemical Reactions and Solution Chemistry. A lot of this stuff should be review, so hopefully this isn't new to you. It should make sense. And if you have any questions, though, make sure that you bring them to class. So water is, we talk about water all the time as being a universal substance. And if we're going to try to dissolve something, whether it's a stain or a salt or we're cooking in the kitchen, we're always trying to dissolve it in water. And the reason that we are dissolving in water is because it is a highly polar substance. And what does that mean is that it has unequal charges. Well, those unequal charges are a great platform for trying to get something to dissolve. That's an R. So if we take a look at our water molecule over here, you should recognize, and if you remember from General Chem, that these have lone pair of electrons, and these lone pair of electrons have to take up space. And so this causes this to be a bent molecule. These are negative, and they are going to repel each other, so they're taking up more space here, causing the hydrogen atom to move down a little bit and causing this to be a bent molecule. We can also take a look at the electronegativity. This end is slightly positive, so that means the oxygen has more ability to attract. These uneven charges, again, makes it easy for things to dissolve. And hydration is the addition of water to an ionic solid. Again, ionic is a metal to a nonmetal. We are transferring electrons, which results in dissolving. Now, if there is enough space, things are going to continue to dissolve. So you need to think about these water molecules that as they, fill up a bucket or a beaker or whatever it is, there's space in between these water molecules so that this salt can fit in between and continue to dissolve. Now, if we have an aqueous solution, you should recognize this, that we are writing AQ behind all aqueous solutions. So if we fast forward here, move on here to dissolving the process of a salt, if you take a look down here, you can see that we have our water molecule slightly negative on one side, the oxygen side, slightly positive on the hydrogen side. Well, if I take a look at my salt molecule, all salt molecules are going to be crystalline shaped. They have a nice orderly pattern. You can see I have the negative anion and then a positive cation and an anion again, positive and negative and positive, and again up and down in this nice orderly fashion. So the water molecules are going to be attracted. So you can see here this water molecule is slightly negative on this side, so it's attracted to this positive side here. And if I look over here, here's my hydrogen that's slightly positive is attracted to this negative side of the salt. And what they do is they just wrap themselves around. You can see this picture here of my anion, that all these water molecules, because my anion is negative, the hydrogen side is attracted to it. And they're going to continue, if you can think of it, is bombarding this and crushing it down until there isn't any more space inside my solution. So the positive ends and the negative ends are what make things attracted to each other. If you don't have that charge there, you're not going to be able to conduct a current, and some things will not dissolve. So here's our example. We have sodium chloride, which you can see up there. The positive ones is the sodium. The chlorine is the larger molecule, has more protons and neutrons. Ions move independently of each other until the concentration becomes too high. So you can kind of think of this as a room full of people. If there's not too many people and you want to go talk to someone on the other side of the room, and you can independently run right over there and talk to them. But if the concentration becomes too high, it's a lot harder to move around in that room. The same thing goes with dissolving. So the solubility of this, though, is going to depend upon the attraction. If there is an attraction here, it's going to be highly soluble. If there's only a slight attraction, then it's going to be slightly soluble. And if there's no attraction, it's not going to be soluble at all. Well, of course, there's factors that are going to affect whether or not something can dissolve. Surface area. All right, if we have a nice cube like a sugar cube or something like that versus sugar that's been pulverized, well, the greater the surface area there is, in this example right here, the easier it is going to be to dissolve. Temperature. Think about a pan of water on the stove and trying to dissolve some salt or sugar into it. The greater the temperature, the ions, the water molecules are moving around faster, the ions will have more space, it's going to dissolve a little bit easier. Now, if you increase the temperature, you're creating that craziness going on inside the solution. You can also create it by agitating your solvent, meaning just to stir it. The energy of the system, whether it's releasing energy or taking in energy, what type of bonds there are, all of that has to do with the dissolving process, and then the bond strength within the system. We'll talk more about bond strength in, I think it's chapter 10, and the different types of bonds there are. Now, we've talked a lot about like dissolves like last year, that ionic substances dissolve ionic substances, and polar substances dissolve in polar, and nonpolar dissolve in nonpolar. But every once in a while, we can get water to dissolve some things that you may not think it should dissolve. So how can water dissolve a non-ionic? Non-ionic means that it's not a metal to a nonmetal, it's not a salt. How can it dissolve a non-ionic substance? So here's my water molecule here again. We know that this oxygen side is slightly negative. We know that this is slightly positive, and this is going to be slightly negative in this situation. If you take a look over here, I have a carbon atom bonded to another carbon atom with 3 hydrogen around it. It's very satisfied. There is no excess charge on this half here. Well, the reason that it's able to dissolve this is because this right here is going to be a polar bond. I have a difference in charge. One is slightly positive over here, slightly negative over here. And so this is called an alcohol functional group, an OH. Well, you can see it's like half of a water molecule. There's going to be some attraction there. When that attraction happens, it's going to be able to dissolve it. Okay, so that is my first section that I have here. So I'm going to stop here, and I think you have some book questions, and a few of them you'll be able to answer from this section. I'm going to continue to do section 4.2, and that one also will be posted. Have a wonderful night.